Uh, Good morning, my YouTube viewers. It's Crystal here. What I wanted to do this morning is I wanted to do a code review for you for the ConnectX competition on Kaggle. But unfortunately, I can't use my own code because I'm just learning reinforcement learning. And because I'm just learning reinforcement learning, I had to copy this code from somebody else. But I did try to clean it up, and the reason why I tried to clean it up is because, he had a lot of things in the code that I wouldn't have put in there. But I copied my code from Leonardo Verigatti, and maybe he copied it from somebody else, but I decided to go ahead and do a code review. And so, this is a very good piece of code. It's the best piece of code I've found. And you can see that it's giving a good public score. It's giving a better public score than we got from the random algorithm and from the center algorithm. So that's good. And that's why I thought, well, I'll go ahead and do this code review. I've also made the notebook public. I was going to make it private because it's not my code, but I decided to go ahead and make it public, and the reason why is to give other people a chance to look at it. So, and try to get in on this ConnectX game, because the reason why is I watched this video about people on Kaggle saying that ConnectX didn't have very many teams, and the reason why is because it didn't offer any monetary prizes. But I think that there's more to it than that. I think reinforcement learning is very difficult for people to grasp and very difficult for people to pick up. And so there are other competitions that people can enter that are not as difficult as ConnectX. But we really need to start learning reinforcement learning, because reinforcement learning is the way of the future. And the reason why is because reinforcement learning is a part of machine learning. And machine learning has supervised, unsupervised, semi-supervised, and then reinforcement learning. Now, supervised, unsupervised, and semi-supervised, you've got a library called sklearn, which is a very good library that you can learn a lot about those three types, genres in machine learning. But I'm still learning reinforcement learning. I'm going to have to take a lot of courses and do a lot of studies. But that's going to be the way of the future, because supervised and semi-supervised learning has labels. So because it has labels, you have to make predictions on the labels. And unsupervised learning doesn't have labels, but what it has is you can cluster it. You can use clustering to find out what's going on with unsupervised learning. But reinforcement learning doesn't have any of that. Reinforcement learning doesn't have any data, and the reason why is because the computer is supposed to learn from experience. And that's the way of the future, because people don't want to have to keep providing data, and with reinforcement learning you don't have to provide data. So that's what's going to be going on in the future. And I'm really surprised that Kaggle does not have more reinforcement learning competitions that people can enter, since this is going to be such a big thing. At the moment, they're using reinforcement learning for games, and that's hard for me because I'm not much of a game player. But obviously games are good because games help you to adopt skills that you normally would not have adopted. So that's one thing that I personally need to do more, is get more involved in games, because I'm sure that games use different part of your brain than other types of work. So whereas I'm very skilled in some areas, games is one area that I'm not very skilled in. So that's something that I need to pick up. Another area where they're using reinforcement learning is self-driving cars, and they're also using reinforcement learning to make predictions on stock prices. Those are just 3 areas that I can think of right off the top of my head. So I personally am going to start studying reinforcement learning more. So we get to the algorithm, and this guy said he used Keith Galley's work, and I have actually studied Keith Galley, trying to learn Connect 4 with the videos that Keith Galley has made. I did the first 2 videos that he did because they were just basically on, text input. But the 3rd and the 4th video I didn't do, and then he has a 5th video where he does it with AI. So I'm assuming that the person who wrote this program is working on the basis of Keith Galley's 5th video. So the first thing that we're going to do is this program was written in Kaggle's Jupyter Notebook. And so it was written a little bit differently from their other competition questions. But one thing that is the same is they had to import the OS file, and then they had to run through the operating system and get all of the files. So he's loaded up all of the files that he's going to need. And then all of these files, some of these files, not all of these files, set up the environment that's necessary to run this game Connect 4. And then now we're going to go to the code itself. And so what he did was he called this agent Little Pumbaa. So I've never heard of that before, but that's just what he called it, Little Agent Pumbaa. And so I didn't want to make any changes to the functions that he made. So that's what his agent is, Little Pumbaa. But one thing that I found that was really strange was he had to import the libraries within the function that he had created, because I tried to import the libraries outside of the function, and when I imported the libraries outside of the function, the program went into error when I tried to submit it. So because of the way that this program was written, the libraries have to be imported inside the function, and the libraries aren't imported inside the function, it'll go into error. So he's got some code to check the score of every board. So I think he's using a bit of so he's got score equals 0, call count equals config.columns, row count equals config.rows. So he's going to center the score. Center underscore array equals int I for I in list board to call count divided by 2. So what that does is that centers the array. Center count equals center underscore array dot count piece. Score equals score plus center count times 2. Now he's going to check for the horizontal. For R in row count, row array equals int I for I in board R to the end. For C in row count, range call count minus config inner row minus 1. Window equals row array C colon C plus config dot inner row. Score equals score plus evaluate window piece. Now it's going to check the score for the vertical. For C in range, call count, call array equals int I for I in board, and then from the beginning to C. For R in row count, for R in range, row count minus config dot inner row minus 1. Window equals call array, and it's going to be R to R plus config in a row. Score equals score plus evaluate window piece. Now it's going to score diagonal for R in range row count minus config dot in a row minus 1. For C in range call count minus config dot in a row minus 1. Window equals board R plus 1 C plus 1 for I in range config dot in a row. Score equals score plus evaluate window piece. Now score is going to check the score of diagonal negative. For R in range config dot in a row count. For C in range call count minus config dot in a row minus 1. Window equals board R minus 1 C plus 1 for I in range config dot window. Score equals score plus evaluate window piece and then return score. Now it's going to simulate the drop of the piece. Def drop piece, and it takes board call piece config. Next grid equals board. For row in range, config dot rows minus 1. If next grid row call equals 0, you break. Next grid row call equals piece, return next grid. Next thing we do is we evaluate the score of each window, horizontal, vertical, positive diagonal, negative diagonal. Tuning this scores, you can get a better score. So def evaluate window, it takes windows in piece. Score equals 0, empty equals 0, op piece equals 1. If piece equals 1, op piece equals 2. If window.count piece equals 4, score equals score plus 100. If window.count piece equals 3 and window.count empty equals 1, score equals score plus 15. If window.count piece equals 2 and window.count empty equals 2, score equals score plus 5. If window.count op piece equals 3 and window.count empty equals 1, score equals score minus 80. If window.count op piece equals 2 and window.count empty equals 2, score equals score minus 20. And then you return the score. So now it asks, is it a winning move? Def winning move, and it takes the board and the player and the config as input. Horizontal winning call count equals config.columns. Row count equals config.rows. For C in range, call count minus config.innerrow minus 1. For R in range, row count. If board R C plus 1 equals player for I in range, config.innerrow equals true for J in range, config.innerrow, and it returns it. Then it says vertical winning. For C in range, call count. For R in range, row count minus config.innerrow minus 1. If board R plus 1 C equals player for I in range, config.innerrow equals true for J in range, config.innerrow, return true. Now it checks for positive diagonal ranking. For C in range, call count minus config.innerrow minus 1. For R in range, call count minus config.innerrow minus 1. If board R plus 1 C plus 1 equals player for I in range, config.innerrow equals true for J in range, config.innerrow, and then you return true. Then you go negative diagonal winning. For C in range, call count minus config.innerrow minus 1. For R in range, config.innerRow -1 row count. If board r-1 c+1 equals player for I in range, config.innerRow equals true for j in range, config.innerRow return true. Then here's another function. Def is terminal node. Board, it takes inputs board, valid locations, piece, op, piece, and config. Return winning move, and it takes in, and then it returns board, op, piece, config, or winning move, board, piece, config, or len valid locations equals 0. So it gives you a list that it's going to return. Implementation of the algorithm. And now what he's doing here is he's going to be using the Minimax algorithm, and that is an algorithm that is used to win the game, really. Def Minimax algorithm, and it takes in board, depth, alpha, beta, maximizing player, obs, config, piece, op, piece. Valid locations equals C for C in range, call fig.calls if obs board C equals 0. If depth equals 0 or is terminal node, board valid locations piece op piece config. If is terminal node, if winning move board piece config, return none math.inf. I think that's infinity, but I'm not sure. LF winning move board op piece config, return none, comma negative math.inf. Else return none. Board position score board piece config. If maximizing player value equals negative math.inf, best call equals random.choice, valid locations for call and valid locations, board copy equals board copy, new board equals drop piece, board copy, call piece config, new score equals Minimax algorithm, new board depth -1, alpha, beta, false, obs, config, piece, op, piece 1. If new score is greater than value, value equals new score, best call equals call, alpha equals max alpha value. If alpha is greater than or equal to beta, break. Return best call value. Else, value equals math.inf, best call equals random.choice, valid locations. For column and valid locations, board copy equals board.copy, new board equals drop piece, board copy, call op piece config, new score equals minimize algorithm, new board depth -1, alpha, beta, true, obs, config, piece, op, piece 1. If new score is less than value, value equals new score, best call equals call, beta equals min, beta value. If beta is less than or equal to alpha, break. And it says return best call value. So that's it. So now it says you get a list of valid moves. So that was it for the Minimax, I believe. So valid moves equals C for C in range, config.calls if obsport C equals 0, grid equals np as array obs.board, reshape config rows, config columns, piece equals obs.mark, op piece equals 0, if piece equals 1, opt piece equals 2. Best call Minimax score equals Minimax Algorithm grid to negative math.inf math.inf true obs config piece opt piece, and it says return best call. So that was it for the main piece of code, and the algorithm that sort of like does most of the work is the Minimax function. So we had all this to do with the Minimax function, and so that's basically what I wanted, was the Minimax function. And so now we're coming to the end of the program. We import inspect, import OS, def, write agent to file, says function file with open file A, if os.path.exist file, else w as f. So that's some Python code. So I'm normally accustomed to dealing with pandas, but this is Python code that it's using. F.write inspect get source function, print function written to file. Write agent to file, says little agent Pumbaa, and then it says submission.py. And that's it. And then so like when I saved the file and submitted it to Kaggle, the best score that we got is 836.3, and that was much better than the random score and the central random score. And unfortunately, you know, I can't do much with this program. I'm going to be working more on reinforcement learning to try to hone my skills, and then who knows, maybe one day I'll be able to write my own game in reinforcement learning, and that would be great. So I'm going to go ahead and conclude this video. I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And I look forward to making more videos for you in the future. And I'm also going to leave a link to the code in the description box down below.